Hi everyone. Uh-oh, I hear I hear our music somewhere else. Do you also hear it though?
I do.
Oh, yeah, I have to find this. Okay, hopefully I managed to turn it off. Hi everyone, welcome to the AI Show Live. We are going to meet with Will Buchanan today and talk about GreenerAI. And let's see. Hi Edward, we already have some people saying hi. Thank you, Will, for joining in. This show is kind of like the behind the scenes, like how we record the little segments. So if you have any questions before we start recording, anything to say, you can do that. I don't hear you. Oh, okay.
Oh, yeah. Hey, everyone. Really excited to be here. Really especially excited to announce some new resource metrics for Azure Machine Learning.
Awesome. People will start rolling in slowly. Oh, Ruth is here too. Hey. Hi, Ruth.
Hi.
You might not have met. Ruth is my coworker, and after we record the segments, then she's gonna help us answer the questions too.
Hi, Will.
Hey,
And
good to
she's
meet you.
going to talk about Metrics Advisor. Hi, Ruth. All right. Well, if you are ready, we can get started with the recording.
Sounds good.
Okay. So I'm going to remove you, Ruth. Thanks for coming. Yeah. Keep your eye on the questions for us.
Sounds good.
All right. Welcome to this episode of the AI Show, where we talk about GreenerAI with Will Buchanan. Hi, Will. Welcome to the AI Show. And can you introduce yourself and tell us what you do at Microsoft?
Hey, everyone. My name is Will Buchanan. I am a PM on the Azure Machine Learning team, specifically focusing on user experience and decarbonization of AI.
That is great. So what are some of the problems that you're solving?
So I've been working on something called GreenAI, which has become a recent hot topic in the news. And it's really specifically focused on providing a set of tactics that data scientists and developers can use to reduce the carbon footprint of their machine learning workloads.
That is great and very timely, indeed.
It is. We're out of time, in fact.
All right. Can you tell us a little bit more about the services, the GreenAI services, and what we do?
Certainly. So within Azure Machine Learning, we have launched a set of resource metrics which provide transparency into the computational costs as well as the energetic costs of your workloads. And really, we're trying to provide transparency to help empower developers to make decisions about when and where they should be running their models and how to optimize or make decisions which would be more environmentally friendly.
Mm-hmm. And how can developers do that? Make more informed decisions?
The first step is transformation on transparency around those metrics. So we're providing those metrics to help users understand the costs of the models, but soon we also have a set of recipes or samples that any practitioner can use and start understanding the savings of their workloads.
Mm-hmm.
So I can walk through that in a second.
Great. We would like to see it.
Sure. And before I dive in, I will give a bit of context.
Go ahead.
So I've been leading an initiative called GreenAI at Microsoft, and it has about 200 people in it across the company. And the reason we're doing this is because you really can't manage what you can't measure. So we're showing a set of early research and innovation that's happening across Microsoft. So we're going to talk about some new capabilities, as well as a few different use cases and validation tactics, and then a few tips on getting started. In terms of where we are today, we're in a state of something known as red AI, and we've created a computational megafauna. So you have state-of-the-art approaches that are buying incrementally better results with high hidden costs. So computational costs have increased in machine learning about 300,000 times from 2012 to 2018. And according to an article by Wired, only about 11% of firms are seeing what can be called a significant return on investment for their workloads. And it's pretty shocking when you think about that. Some recent studies have shown that the GPT-3 training emits as much carbon as 3 round-trip transcontinental flights from San Francisco to New York. And Emma Struble, about a year or two ago, also published a seminal paper which compared a transformer model with a round-trip flight or a human life or a US car. So a 213 million parameter transformer model training consumes as much carbon as 5 cars, including gas. So as you can see in this chart, we have surpassed what could be seen as Moore's law, and we're in more of the extreme modern era of computation where it's doubling about every 3.4 months. And the AI market is going to grow about 44% annually through 2025. And we believe that there will be a point of inflection where there are diminishing returns, where the marginal cost benefit ratio are no longer worth the additional investment. And a bit of background on AI pipelines. So it consists of both training and inference. In training, you are teaching a model how to make predictions based on existing data. And generally, you're doing long runs and a few of them. And then when you go to scale, you infer your model, and you're applying this trained model to make predictions from data that it has not seen before. Generally, it has short runs and lots of them. And emergently, there is specialized hardware such as GPU, which is optimizing your workloads there. And they are often power hungry, consuming about 300 watts on average. As I mentioned earlier, it's a pretty hot topic in the media these days. Had a chance to chat with Timnit Gebru, who published the Stochastic Parrots paper, and she's really saying how it is past time for researchers to prioritize energy efficiency and cost so that we can reduce environmental impact and increase equitable access to resources. So you can think of the AI industry in some ways as similar to the oil industry. Once you mine and refine your data, it can be highly lucrative, and it seems that this metaphor could extend even further. And the way that we're addressing this is through a cost metrics framework. In terms of the costs, we want to expose both monetary, the computational runtime, the energetic costs, as well as utilization for both training and inference. And it's important with training because only about 12% of the models that you're making actually make it into production. And for inference, according to an article by NVIDIA, it accounts for about 80 to 90% of the carbon cost of a model. So the vision that we're working towards is an operational lifecycle analysis monitoring toolkit. So you can assess these different cost frameworks for both training and inference, and then set a set of triggers or tools you can start to optimize your return on investment. So the first capability that we've done, you can see in Azure Machine Learning Studio. In the user interface, you can add an opt-in metric to see the GPU energy cost for your runs. This helps you find the most energetic culprits, and then you can sort to discover which ones are the most expensive. We're also offering the same capabilities for both utilization, GPU, and memory. Next, you can see some additional screenshots in the monitoring tab, which is in preview. You can view a real-time plot of your GPU energy usage broken down by node. And, you can also see CPU utilization, GPU utilization, and memory, and of course, energy. And so we've done a study where you perform a batched inference run. And we calculated the cost per million inference, which is the standard framework for inference. So it consumes about 13.8 kilowatt hours. And that's about half of a US home's daily energy consumption.
Oh, wow.
Yeah, it's crazy.
It is.
And so if you were to convert that to greenhouse gas equivalencies, that'd be about the same as 24 miles driven or 11 pounds of coal or a gallon of gas. So you can imagine this really adds up over time. So the analysis we did was for the BERT model using a TensorFlow framework on a V100 with 32 floating point precision and 16 batch size of 16. We ran it for 2.5 hours, and we calculated the throughput as well as the energy cost, and then we extrapolated that for 1,000,000 inferences. So as part of our work, we've been working with NVIDIA on something called the Triton Inference Server, and this is specifically designed for high throughput inference workloads. It comes with a number of benefits, such as model concurrency, where you can load multiple models or copies of that model onto a GPU and then execute them simultaneously. Another exciting feature is dynamic batching, where you can dynamically group together your requests on the server side to maximize your performance. And mixed weights precision. Due to the vanishing gradients phenomenon during your training on a backward pass, your models you typically trained using floating point 32 precision. However, given for inference only the forward pass is necessary, you can use a lower precision such as 16, and Triton allows use of both of these. So on a similar analysis, we found that if you used mixed weight precision, you can cut your cost by greater than 50% just by switching from floating point 32 to 16 using the Triton Inference Server. And you can see the cost per million inference is significantly less, almost a third. And GPU power consumption is from about 75 to 60 watts.
This is great.
Something else we've also been working on and will soon be releasing, there is work with the NVIDIA Model Analyzer. So you can analyze and develop the optimal configurations for your model. And we also charted the relationship between power efficiency and GPU utilization. And so if you use Model Analyzer to optimize your configuration, you can reduce your cost per million by about 12.6x. And here you see the chart with the baseline there. So the baseline is compared against ORT and CUDA as the backend versus the TRT backend optimized by Model Analyzer. So using the Model Analyzer can automatically maximize both your GPU utilization and your throughput, and consequently save energy. And finally, an additional case study that we've done. For the image classification scenario for training, we compared two different convolutional neural networks, Inception v3 and DenseNet. And both of these classify images with greater than 75% accuracy on your ImageNet dataset. And so we compared these two models for both energy usage and cost savings to help determine which models give you the results you need at the lowest cost, both monetary and environmental. And so we found that Inception v3 outperforms DenseNet in terms of accuracy, coming at about 10% higher. Also costs about 13% less and uses 20% less energy and about 10% less training time. So really key to this, and this is the foundational tactic, is choose the right tool for the job. Start to think about the networks that you're choosing and the costs that incurs for your business.
You're not only saving the environment, but you're also paying less, which is great.
Yeah, I agree. It's the real business case for this work. So we're just getting started doing GreenerAI, and we hope to bring additional people in to work on this. And so we'd like to work with any customers to define what carbon awareness and energy efficiency might need for their organization. And specifically, we'd like to point you to the Triton Inference Server to get started doing that. And also, we will share some recipes and samples to help compare these cost-benefit trade-offs. And I did want to throw in a plug for the Green Software Foundation, where we're starting to define this concept called a software carbon intensity specification, and that is currently the alpha version is live. So if you look up Green Software Foundation on GitHub, you will see some really exciting work there. So that concludes my presentation.
Great, thank you so much. This is really exciting. And where people can learn more about GreenerAI?
So we have a blog on the tech community, which outlines some of this that I showed here, specifically the resource metrics. So maybe we can post that into the chat for everyone.
Yes, we have it below the video as well.
Oh, okay, great. And also, I believe we're posting the link to the Triton Inference Server.
Yes.
So I think that's the best starting point, but stay tuned. We'll have a lot more exciting news soon. And especially with the Green Software Foundation.
Thank you very much, Will. It's very nice to have you here, and we'll have you back again. Okay, I'm gonna cut this part. My cat is trying to get in. It's so distracting. So sorry about that. All right. Since I'm gonna cut it, is there anything else that you would like to add before?
I think that's everything.
Okay, great. Thank you.
Thanks.
All right. Okay. Where is my stuff? I will remember this. Thank you for joining, Will, and thank you for telling us about the GreenerAI. We'll see you next time.
Great. So we're done? Okay.
Yes, I'll add the banner at the end of it. I'll try it one more time. Just
Okay.
Okay. I was clicking on something else. Thank you, Will, for joining us and telling us about the GreenerAI and how we can save more money and the environment. We'll see you next time. Uh-oh. All right.
I'm back.
Yes, lots of distractions. Hi, Ruth.
Hi, Aysegul. How are you?
Good. How are you?
I'm doing good.
Hi, everyone on the chat. Sorry, we weren't able to answer any of your questions there, but now we can. So ask it away. Do we have any questions?
I believe we have a question from Sarafuddin. And his question is, can we use GreenAI in web application development?
So I don't think you can use, well, it depends how you develop your web apps. For one, GreenAI is more specifically focused on machine learning tactics. However, the field of carbon awareness is something that the Green Software Foundation is really actively working in. And so we're focused on quantifying the software carbon intensity of even a web app or a machine learning job. So we're developing a framework so that you can start to measure and then reduce this. So I think that's the best way to get plugged in for that.
Can you tell us a little bit more about the foundation? What you guys do?
Yeah, so the Green Software Foundation is a cross-industry consortium co-founded by Microsoft, GitHub, Accenture, ThoughtWorks, WattTime, Goldman Sachs. And so we have built a set of working groups. We have three. There's a community working group. Which is focused specifically on developer tooling and outreach and building mindshare on this problem. And then there's an innovation working group where we start to build the tools to start to save carbon for your, say, your web app or your machine learning workload. And then there's the standards working group, and it's the one I've been most heavily involved with. And as I said, it's come up with a software carbon intensity specification, which means you can start to measure and then reduce the carbon of your workload.
Is this an open source initiative since there are different companies involved?
It is. It's fully open sourced on GitHub. I will see if I can pull the.
I think
GitHub
the
link.
audio kind of muffled over there.
It's
it's frozen.
GitHub.com/green-software-foundation.
Awesome. You got that, Aysegul?
Dash foundation. I hope so.
And do you mind repeating again, Will?
I just pasted it into the private chat.
Oh, awesome. And is there any other tools like that you like that are built by other companies other than Microsoft too?
Well, the Green Software Foundation has also published an awesome list, which is what we're calling the curated list of best practices and tools. I think Code Carbon is a really good one. It also helps quantify the carbon cost through machine learning. It's really exciting because this is such an emergent space. So I really love the open source aspect of this too.
Since it's open source, I mean, does that mean people can contribute, join? How does that work?
Yes, please. It's all open source through GitHub, so anyone can fork and then issue a pull request. And if you are from your organization, we welcome you to join the Green Software Foundation so we can start to formally induct you into the process and the working groups.
And how did you get involved, Will?
I've been deeply involved in sustainability work at Microsoft since I joined about 2 years ago. And so one of my close colleagues, Asim Hussein, was the chair and founder of that. So it was pretty easy to get pulled in. And most of the core players in the GreenAI group are also part of the Green Software Foundation.
That's great. Yeah, awesome is really awesome. Yeah.
Yes.
Yeah, we used to speak at similar conferences. So I knew him before I joined to Microsoft. And I was so happy he was so excited about the GreenerAI. And I know that GitHub has done some stuff, but what are the other things that has been done at Microsoft?
Well, Microsoft has many different great sustainability initiatives. I think the sustainability calculator is one of the cooler customer-facing tools that have been built. And so we're taking a bottom-up approach, and we're hoping to integrate this GreenAI measurement work with the sustainability calculator. I think it's called the Emissions Impact Dashboard now.
Mm-hmm.
Is this something that is a flag that's enabled, or is it a configuration within the script that people can incorporate when they're running some of their experiments?
So all of the resource metrics on Azure Machine Learning come included if you're running on Azure ML batch compute on a GPU. So that comes by default. And I will paste the link to the resource monitor in the chat so that we can ensure that everyone gets started with that.
Okay.
So I think there are about 100 different resource metrics that you can take advantage of.
That's good.
Here we are. Into resource reference. Okay, cool. And one last question. I mean, you might not be able to answer this, I understand, but what are the future plans for your team?
I can't speak about it in detail, but as you can tell, I've been talking about the Green Software Foundation a lot. And that's where primarily we'll be focusing our efforts and releasing some open source tools in this space.
Great. Well, thank you. So everybody on the chat, if you have any other questions, ask it away to Will. Is there any place that people can find you, Will? Are you on Twitter or anything?
I'm not on Twitter, but
Okay.
I think you can look me up on LinkedIn if you want.
GitHub, yes.
Yeah, I'm pretty active on GitHub.
Okay, great.
Is there also a community group that people can join chats and look at prior, like frequently asked questions once they get started?
We have not created one for GreenAI. That would be an interesting approach. Yeah, right now we're doing it through OCV feedback for users of Azure ML, but it'd be great to connect directly with people that are trying to do GreenAI.
Okay.
Yeah, this is great that you have the awesome list of the softwares too. It's nice to be able to find everything in one place. Okay.
Yeah, it's been really fun to compile that. And we've pulled many of the developers from those tools into the Green Software Foundation as well.
Awesome.
Yeah, definitely sounds like a good initiative. Because usually when we're developing any training, we just toss a whole bunch of compute servers and cross our fingers that it does produce what we want at a given time. And it's robust enough. So that's good to know that in the process, we are also conserving the energy.
Yeah, it is really important to do that. And also, just as I said earlier, choose the right tool for the job. And eventually, it would be great to include features like cost thresholds for your jobs. Very simple tweaks can start to create a lot of savings.
Mhm. That's true.
Yeah. Thank you. Looks
Let's
like
see.
now. Go ahead.
Now I'm trying to see if we have any more questions from the chat.
Yeah, I don't see any. So we'll let you continue to your day, Will.
I see a lot of excitement, that's for sure.
Yeah. All right. Thanks for joining, Will. We'll
Thanks for having
do
me.
this again, hopefully, sometime soon. All right.
All right. Take care, everyone.
Bye.
Yeah.
Bye.
Bye.
Hi, Ruth.
Hi, Aysegul.
We didn't do a very good introduction for you. So can you introduce yourself once more and tell us what you do?
Okay. So my name is Ruth Yakubu. I'm a cloud advocate at Microsoft. I'm on the AI and ML team. I've been with the team for about 4 years now. And basically what I do is to reach out to the developer community to try to bring awareness to our AI and machine learning services and get them excited to try out our services and see how it applies to what they're currently developing.
Mm-hmm. And you did work with the academic teams as well, right?
Actually, for the past 2 years, I've been working with the startup community. Um, so that was fun since I have a background in startup. So it was good to work with that community because I feel like when you're in the startup realm, time and money is of essence.
Yeah.
So you can't pick something and think it's going to work. Then down the line, you backtrack and maybe have to refactor. So it's very important to be crisp and concise and make sure you answer all their questions and also make sure they do understand what they're getting themselves in. So it's kind of like we put ourselves also in their shoes to guide them along. So once they get in, they know what's going on and they do appreciate our services and what it has to bring to the table. So did that for I'll say about 2 years. So now I'm back to the open general developer community. So that
So
includes enterprises, developers, well, not students, but yeah, developers in general.
lots of different problems, right? With the I mean, I don't know if you worked at the startup. I did two startups as a second hired engineer. One of them was an AI related, and you don't have time. You don't have many people who are working on it, so time is the biggest thing. But when it comes to enterprise, I feel like scalability is the thing, right? Like because
You are so right. So when I joined Microsoft, I actually came in as a cloud solutions architect. So of course we're working with the Diamond clients. And yeah, they have all the money, but it's all about scalability. If I move from one cloud to another, and they have all the money, how can we scale? How can we meet the needs of all our different customers, that sort of thing. A lot of them were also partners, so they had, when I say partners, they could work, it could be, let's say, like an Accenture, but it wasn't one of our partner at the time, but they had individual customers that they're catering to. Let's say you're dealing with Boeing, Warner Brothers, that sort of thing. I'm not saying they're a client or I'm denying, but just an example. They're working with big enterprises and they have to come up with solutions quick. So there are a lot of POCs and yeah, a lot of how can we take the current work that we're doing and take it to the next level? And by the way, our competition is doing that. So we needed this implemented as of yesterday.
Yes.
So that was interesting, but a very good learning experience. Then when you're with startups, um, they're brilliant. It's like, for me, I got the high out of just talking to them and finding out all the amazing stuff that they're building in the AI space. And then trying to either advise or provide demos or workshops on what our services are and how it caters to aligns with what they're trying to do, that sort of thing.
Yeah, startups are exciting. I worked in a co-working space which had tons of startups, and it was like you would see the drama. One day they're there, the next day they might not be. So, yeah, money runs out. It was an interesting experience. It was actually nice to see all of those at the same place.
A lot of fire drills.
Yeah, yeah.
Yeah,
Well,
it's
yeah,
special.
I know. Now I know. It is really hard work. Like not all of the startups make it.
Yeah.
It's really hard work. Would you want to join or have your own startup one day?
Well, I had my startup one day. When I left, I think I was running. No, but I enjoyed the time.
Yeah.
Would I go back? There were a lot of lessons learned. Would I work for a startup? That's also a question mark because with startup is exciting, the vision, but you do wear a lot of hats.
Mhm.
So a lot of enterprises have the resources, but with startup, there may be limited amount of resources and specialization. So even if you want to do X, Y, and Z, finding a data scientist is one thing. The next thing is, can you afford them? That's another
Yes.
another thing as a startup. Then a lot of them may be wearing a lot of hats. You could have the same person, the data engineer, that's also the data scientist, and it's just, and they may be have another title too. So you're dealing with the limited resources. So that's why our team was very sympathetic for those type of situations, to really have good understanding of not just what you're trying to do,
Mhm.
how much manpower do you currently have,
Yeah.
and what is, like, in terms of go to market, what do you need right now versus down the road.
Mhm.
And Aysegul, you're like the rock star of cognitive services.
Thank
It
you.
To me, it solves probably like 80% of some of the common use cases.
Mhm.
So in those cases, can they leverage something that's pre-built off the shelf that does a lot more than what they can build in a year? Even if they want to build it, where are they going to get the data? So that,
Exactly.
yeah.
Yeah,
So
I was gonna say that. Like, I feel like AI startups are a little bit more riskier because you don't know if your data is good. You're gonna get the result that you're expecting. So,
yeah,
I mean, it's not like building, any other product. There's lots of ambiguity in, yeah, you could
yeah.
collect the data for about 3 years and then like nothing comes out of it. What do you do after?
It's like, I've been running this. It's still at 30% accurate. What do I do? It's
Yeah.
not funny, but it's a common pain point. And Also, listening to Will's talk, it's much needed as we're building these experiments and models. Okay, how can we think of consumption, green wise and also monetary wise? They all go hand in hand too.
Yeah, that is
Yeah.
true. Was there any difference between the tools that enterprise using versus the startups were more inclined to use?
Um, I think it was pretty much the same. When it comes to AI and machine learning, to be honest, everybody has their processes and their favorite tooling. Then in the whole AI ML pipeline, building end-to-end solutions. So I won't say I saw um, more of this versus that, that sort of thing. Um, with the startups, a lot of them, they'll build things locally. Then once it comes to, okay, we need the robust compute, then they'll come to Azure and leverage the compute in the beginning. But once they're comfortable, then they start taking advantage of some of the services and products that we have in the Azure Machine Learning Workspace that provides seamless end-to-end ways and even tracking of your experiments data, especially when you're working with multiple teams that are doing different things throughout the pipeline. So that's when they get excited that, oh my God, we have this all in one place. Let's utilize it, because right now we're using probably 3 different toolings or open source software out there.
Hey everyone, ask your questions to our expert here. If you have startup ideas, or we have the expert here, so ask it away.
We have 2 experts here.
Oh, this is. What is your favorite tool to recommend?
My favorite tool?
Yes, like there's lots of different, services and tools but what are the ones that you recommend the most?
So for me, I'm like an instant gratification type of person. So I love my Jupyter notebooks. Yeah, after it works, okay, let's figure out how we can put in differently into Python and whatnot. Then the whole, once you have your model created, that whole pipeline to containerize it, deploy it into like Kubernetes, coming up with your scoring files and whatnot. If you're to do it manually, that can be time consuming. So I like how our Azure Machine Learning has a very similar way of accomplishing all of that. Even if you're running things locally, there are SDKs that you can connect to. So you're running things, but you can still be tracking your experiments in the cloud. And okay, you tweak things. Okay, what parameter did I use before everything went downhill? I know it was almost ready, but now I'm in a pit. But you can go in there and it tracks everything. I really like that.
Oh, that's great.
Yeah.
Hi everybody. Everybody's awfully quiet today. I hope you are there. I hope we are alive. please say hi at the chat, and if you have any questions. And Ruth is going to show us the Jupyter notebooks, actually, right?
Yeah, speaking of notebooks. Yeah, actually, I kind of got inspired by Will's talk today about GreenAI, figure out ways to consume your carbon footprint while you're creating a lot of these solutions. So it's funny, I was working recently on anomaly detector, and the use case was, okay, we all have households, and what if we can use anomaly detector to kind of pinpoint, let's say I get a bill, I'm like, good Lord, that's a lot of, my bill just skyrocket high. Where is that coming from? A lot of the power companies or companies out there are creating smart meters that go on the circuit breaker to monitor how we utilize our appliances. And also the goal is to reduce the household power consumption. So it's kind of helping you recommendations on where you can things that you don't need running, but you don't know it's running. It can pinpoint stuff like that.
Yeah.
Or if you get a spike in your bill, okay, and you call the power companies or the utility companies, okay, where is that coming from? I know I was on vacation in December, so did somebody come in and use my power, that sort of thing? So it's a good way to monitor anomalies. And for the use case I use, yes, it is like energy consumption for the household. But taking a step back, this is something that can easily be used, a service that can easily be used in, let's say, smart cars, or you can use it in the retail space if you have like a spike in what's it called, the amount of traffic on your website or apps. You can, and you're gathering metrics around that, you can utilize. A lot of manufacturers are using that. So there are a lot of sensors out there. So if something breaks, they get an alert. A lot of financial institutions also utilize that. So across different industries, anomaly detection is utilized and needed. And I know there's a misconception that, okay, anomaly detection, wait till everything is not working when there's chaos. But it's definite is really like, okay, when is there a change? When should I start monitoring? Because some change is good. So you just need to figure out, okay, how can I do a root cause analysis to figure out what's going on? In a car situation, would you, the end user, want to be driving and your car just stalls in the middle of the highway? No, you could have prevented that by giving me warnings ahead of time.
Let's step back in, like for people who are not maybe familiar with anomaly detection, it's one of our cognitive services that you can build with, and it takes the time series data, right? So if you have a data set that's over time, you can take a look at it and detect the anomalies and, maybe send an alert or do things like that. So we talked about the house example. You would probably not use it in your house to check your electricity bill, but if you have a factory or a big company like enterprise, right, that might be a huge saving tool.
Yeah.
Also, the other example I was thinking was health of your, microservices. I used to do data visualizations, and one of the things that I did a lot of times was creating these visualizations to see like where our software is failing, basically, where people get stuck. To know, because we are using lots of, in a big enterprise, there's lots of different parts of it, right? There is like authentication login is somewhere, and there's some other services that you're using. It was really hard to figure out where we were failing, and
You are
yeah, and solve that. So visualization, like we had it in a humongous screen, so everyone will see, and there was no doubt where it was failing, and it was super helpful. Now you can do that with anomaly detection much faster. Like you don't even have to see it all the time, but basically you can send yourself notifications when something bad happens.
you are so right. It's easy to think of all those situations, but you're right. Data visualization, when you're doing data analytics, I know a lot of people have pipeline solutions that as data is coming, they need to cleanse it or look at anomalies before they get it to the source of truth, then do some kind of analytics on it. So the
Mhm.
good thing, since it's one of our pre-built cognitive services, you can actually inject it in there, and it'll be watching and monitoring and tell you where things are wrong, and you can fix your data before you go and do analytics. So I'm glad you brought up that point, because yeah, that is also, yeah, everyday today life we can do utilize the service.
Mhm.
And like you mentioned, it is a cognitive service. So it comes in two modes. So there's a univariant and
Mhm.
multivariant. So with the univariant is when you have one metric that you're looking at, maybe your data contains something like maybe temperature and a timestamp. So
Mhm.
with that one, the good thing is the API is actually smart enough to look at the data patterns as it reads through the data, and dynamically it will come up with the right algorithm model to suit your data trend to find anomalies. So sometimes, when we look at graphs, they're kind of going up, and you're like, wait a minute, isn't that an anomaly? But no, there is a steady
Mhm.
upward climb, so it's good. Or it could be like hilly, like a wave. But once that pattern is off, then it's able to catch that. So there are different algorithms and models that you have to apply based upon the different data pattern that you have.
Mhm.
If you're a developer or you're a company that has to create models for each of the different pattern, it's like, okay, I see there are probably 8 different patterns. Some are like spiky, spiky. Okay, so that means you have to create a different training and model for each of those different scenarios, which
Mhm.
is not uh, a right approach of doing things. It just takes a lot of time. So the good thing about this anomaly detector is dynamically it chooses the right algorithm for you.
That's good.
Um, and that's in the univariant one. And the univariant also comes when you have like real life data or historical data. Because,
Mhm.
sometimes we have like the sensor situation, we have data coming in real time, like streamline.
Mhm.
So you can utilize that, or you just gather data. It's like, okay, let's make sense of this. Something, do we have like outliers in our data or normal behavior? You can do that.
Mhm. Also,
Then they,
multivariate gives you correlations, right? Like looking at different dimension of the data. Like you mentioned, sensors. If it's temperature, maybe you're also looking at the humidity and see how that affects your anomalies, right?
yes, yeah, because the univariant came first, and we hear from our customers that yes, this is awesome, but it's hard to really pinpoint when something goes wrong. Whenever we're troubleshooting, sometimes it's not just one thing that goes wrong. It's like a domino effect. Something happened that triggered another thing and whatnot. So it's a whole correlation. It looks like the whole picture,
Mm-hmm.
what is going wrong, and then it'll pinpoint all of that. So you do have a view of all the different metrics or fields that you are collecting in your data stream, and it'll pinpoint not just the anomaly, but it'll help you pinpoint what are the contributors are
Mm-hmm.
of the anomaly.
Yeah. Uh, so in my case of the microservices, it will tell, it makes it easier to see which service failed and which was the cause, because once something fails, the others are going to fail. You don't know where it started with one dimension, right?
Mhm.
And also, you do need, because it's a time series, the algorithm has to understand what the pattern is. So you do need the data to feed in. Like it doesn't happen right away, right? Like when you do real-time data, it will take
Mhm.
some time to understand what is the regular pattern versus anomalies.
Yes, you're right. So a lot of people think, okay, as let's say I start reading and it's provided 4 data points in the last 4 minutes or 4 seconds, automatically tell me it's anomaly. No, it takes time for it to watch the pattern. Then over time, it'll start getting the gist of, okay, this is what's going on. And you also have the power of telling it how fine grained you want it to look,
Mhm,
depending on your data. How frequent is it coming? Is it coming by minute? Is it coming by hour? Is it daily? Is it
mhm,
monthly? That sort of thing. So
mhm.
based upon all of those parameters, it's able to um, gather that information, look at it, and provide feedback in real time.
Yeah. Um, well, hi everyone on the chat. Please let us know, like, what do you think you would use anomaly detection for? Um, and let us know, like, what are the other use cases you think that are possible? And we will see it in action. So it might make sense a little bit more. And so we know, well, we've been working with anomaly detection for a while. So we might have skip over some of the details. So if you have any questions, please let us know. We are here to answer. That's why this is live, right?
Yeah, actually, it would be nice to hear how everybody else is using anomaly detection in their everyday life.
Mm-hmm.
Because sometimes we're used to maybe the three common suspects that we know. But when you look at somebody else, what somebody else is working on, it just blows your mind.
Mm-hmm. That's true.
Yeah.
But I have this idea of like recording everything that I do and to see the patterns and like anomalies. Um, and most of the companies know your anomalies about you, right? Like
Mhm.
about their customer, but you never get that information from them. So one day, like
You know, like like some people are amazing at putting together charts, especially with the historical data. They put in charts and all of that, and it's like, okay, you gotta look. Okay, I think there's something going on there. I'm not gonna lie, I'm not one of those people.
Well, the
Um,
thing is Power BI. You'll be just fine.
yeah, I need a tool and some programming, whether it's via Python or Power BI. But some people, when I look at their graphing abilities, it just takes you to another level. It's like, look, this is a work of art.
Yeah, that's true. They're really good ones. One of my favorites is R2D3. Uh,
Oh, yes.
so I'll paste the link. Well, I'll actually share my screen and show it to you. Um, okay, this one, share. Okay. Do you see it?
Yeah.
So this is an introduction to machine learning. But look,
Mhm.
uh, when you move,
Oh, it's like a scattered.
yeah, they explain the concepts with the visual right next to it. So if you go back up, you go back to the same animation backwards. This is so fascinating to me. Like I had hard time reading this article because the visualizations are so cool. This is
Hmm.
like, and these are all of the decisions that you are making.
Yeah.
Yes, yeah, they I'll paste it, paste the link here.
And it shows that there are different ways of also plotting your data. You may plot it using one form, maybe like a pie chart, but it really doesn't uncover anything. You may need like a scattered graph or a line graph, that sort of thing. It looks like we lost her. Let me check if we have any more questions. Not yet. Oh, wow. Yeah, so while we wait for Aysegul, I might as well start the process of sharing this demo on how to monitor household power consumption. So give me a few minutes while I load my data. Okay, there we go. Should be coming up shortly. Oh, I know. Since Aysegul is the admin, she can promote the screen, I think. All right, guys. While we wait for the host to come on, if you can come on board and ask any questions that you have in general for anomaly detection. I'm not sure if I mentioned as well, this also can be used in IoT type of scenarios. So let's say you have your sensors out in the field. You can connect to IoT Hub, your devices to IoT Hub. And part of the best practices is you bring the raw data, let's say store it into a blob storage. And from there, there's some data formatting that you actually have to do, especially telling how the granularity of how your data is. So, like I mentioned, is it by minute? Is it seconds, hours, and whatnot? Then once you do that, then you can start feeding it into the API. So there's a little bit of a cleansing going on in the back end.
Hello.
Hi.
Um,
So I'm ready to share the screen. I have it
okay.
uploaded, but I think I don't have admin rights.
Yeah, I just added.
Okay, cool. I was wondering why it wasn't letting me.
Yeah, I'm the only host right now. Oh, thank you for making it bigger. That's what I was going to ask.
Yeah, I can't see it myself. So,
All right. What are we looking at?
we're looking how to use a multivariant anomaly detector. So basically, these are the APIs, the SDKs that you utilize. The good thing is for those of you using other languages besides Python, it comes in different SDKs. So you'll be able to utilize that in your respective languages. I quickly scrolled by because from there, once you create your anomaly detector instance, um, you need the key of the service, and you also need the URL of the service. So let me share that as well, because sometimes it's good to explain, but a lot of people, it's easier when they see how the service actually
Yeah.
looks like. So let me move it to another screen and share that screen.
While you're doing that, we have a link to the Responsible AI event that is coming up that you can sign up. So let me show you what you will see. So we have corporate vice president Eric Boyd, also vice president, and lots of people joining. And you can. This is a free event, which is December 7th and 9:30 a.m. Pacific time. So if you want to sign up, aka.ms/RAI, sign up. All right. All right.
All right. All right. So I have the screen. If you can bring it up.
Oh, okay, sure.
Okay,
Okay,
let's
can
make it
everyone see?
larger. Okay. So basically, I'm on the Azure portal. So to create an instance of the anomaly detector, you can click on the waffle, create a resource. I usually take the shortcut, and I'll type in anomaly detector, which is this service right here. And that's how you go through and do the creation. So I'm not going to walk through that. Once a resource is created, the next thing you need to do okay, give me a few minutes. This is not responsive.
I hope what happened to me won't happen to you. My computer freeze completely.
Yeah, that's why I was like, wait a minute. It was clicking, now it's not clicking. Okay.
It looks good.
So I'm going to go to my resource group that I created for this demo. So basically, you go to your resources. So when we talk about API keys, basically, let me expand. Basically, this is where you go to resource management. You can click on the keys, and these are where the API key is. So you can click on that and paste it into your code. And also you need the resource name. So basically the endpoint API to utilize that. So wanted to show that. So next, let me bring up.
And remember not to share your keys with anyone or commit it to GitHub.
Exactly.
That's how you get big bills for not something that you've done. And
okay, so let me go ahead and promote this. Okay, so basically what we did was we declared our environment variable. So subscription key, all it is just a variable, and you just assign the API key that we just got from the resource that you created. The endpoint, you create a variable for the endpoint. That's the cell above that I'm hiding because I have my credentials there. You basically paste that endpoint. And from there, the very first thing you're going to do is create a client. So basically, to create a client, you're authenticating the service. So,
and this is using the Python SDK, right?
yeah. So those are, go ahead.
So you're not defining the Azure key credential method. It is included in the SDK. You're just importing it.
Exactly. Yeah. So to create the client, you need to basically provide the credentials. It is going to authenticate. And once you authenticate, you are going to, the next thing you also need is to specify where your data is located. So for this, multivariant is kind of different. The way it is for every data, every metric that you have, all the data you have is going to have two fields in it. It's going to have a timestamp field and a value field. It's comma delimited, and timestamp is obviously a timestamp, and then whatever the value is going to be a numerical float. then you have to save what that metric name is. So how you save that CVS file is actually what is going to go into the feature field when it's trying to do the training. And later on, you guys will see what I mean based upon the output.
So basically, you can't send a JSON with all of the different data points and one time point, but you have to have different documents or data for different variable.
Yeah.
Okay.
So in real life, you have sensors for every single thing, right? So you have a sensor that's bringing temperature data, another one that is bringing maybe humidity data, that sort of thing. So you are reading all of this, only that is saved in, let's say, a CVS file like temperature, that sort of thing. Then once you have that, let's say you just have these two fields, humidity and temperature, those will be two CVS files. You save it as CVS, you zip it.
Okay.
So step one, save it as a CVS. Step two, create a zip file. Then you can choose where you want that data to be. In this case, we're uploading it. Go ahead.
This is for batch.
This is for multivariant. So actually, I'm glad you brought that point up, because for the univariant, you can just send the JSON files. It takes JSON files, so you can feed the same API and whatnot. You can load your JSON, individual JSON files into your blob storage. It picks it up and runs it. But with multivariant, you can have up to, let's say, 200 different metrics or fields that you're trying to get information on. So those will be different CVS files. Just zip all that data into one zip file and store it somewhere.
Okay.
So
this blob source is your blob storage on Azure.
Yeah.
Okay.
For me, the easiest way is blob storage. You can point it wherever you want, but you also have to think about the speed too when you're accessing your data. So blob storage takes a lot of data. And another thing about the multivariant is it's not one of those that you're grabbing, like, let's say 100 fields, data points, and saying, yeah, let's go train this. Chances are your results are not going to be very accurate. You need a lot of data. I'll say around 1,000 or so. For it to fully, especially if you're going to train it, to fully know what's going on.
Yeah.
So the multivariant API gives you the ability that, okay, you have your different use case, you have your business, bring in your data, and it gives you the ability to use this API to train the data that you have based upon how your business works, what's normal for your business. Because financial trends is, for example, one company, their financial trends may be normal for a certain scenario. Another company, those financial trends, if they go a certain way, that's an anomaly, that sort of thing. So you bring in your, go ahead.
This is just to train it so we can see, for example, if you have a conference like Microsoft just had, then your stock might go up or down, but every year at the same time. So you are able to see, if you have years of data, you are able to see all of those. And then when you send the actual like time data, I mean the data that's here, then it's using this trained data to analyze.
Exactly.
Hi, below, and Lyric Central Uganda, we have Pandeka Enoch. I hope I'm not butchering your name. Hi, everyone. I was worried you guys can't put your questions there, so thank you for saying hi. Go ahead.
Well, it's glad to see we have people from all over. That's
Yeah.
always comforting. So basically, the very first thing you need to also establish is it's like any, once you're training a model, you need test data. So in our case, you have a whole bunch of data. You need a start time and end time. That's how you partition how big of a file you're
Mhm.
going to have. So these start times that I'm specifying in here, the model info, is basically uh, a time that I set, a start time in the data, because I knew that looking at the data, I knew I wanted at least 1,000 data points. So I was like, start at this timestamp, go to the end of this timestamp, and that's going to give me 100, at least 1,000 data.
Okay.
Um,
Just for testing, right?
yeah, just for training.
Okay. Okay. Sounds
Yeah.
good.
So once you provide your data feed, the next thing is you're calling the actual train um, method on the client that you just established. So the client made authenticated into the anomaly detector SDK. It passed, is good to use SDK. Now you're passing your data, your starting point, into this multivariant um, function.
Mhm.
And basically, it's going to take the data feed and it's just going to loop through those, what's it called? Start and end time. So once you have that, when your training is done, the response, you're gonna get the model ID. So the model was trained successfully. So this is a trained model. So you just go to the header. It's gonna return a URL. So you're just basically parsing. Yeah, that's a problem with expanding windows.
Wait a minute. Well, we have a comment. Things are hard. Yes, but there are easier ways.
Yeah.
We have this thing called Metrics Advisor. It's much easier, but also this is most of the work is done with the SDK, right?
Yeah,
So
exactly.
yeah, you are basically not writing things from scratch. Can you step back just a minute? So we are trying to train the data. What was this client, self-ed client? That is
So-
our endpoint connection.
Oh, okay. So I didn't include that because I specified all of that in where I'm providing the authentication. But if you notice, I gave it uh, here. So you specify, your data in the CVS. So you just specify start at this timestamp because it is a time series file. So use this extract from this time to this time for training, allocate that data. Then later on, after the model is trained, you also need um, a time range to utilize for when you're actually validating your training or doing inference of your training. So that's where the test is coming into picture. So I know all of this is slow, but I'm just trying to make sure everybody follows.
Yeah.
In real life, look, we'll blow through this in less than 5 minutes. So you got
slow is good. I just wanted to say the client is also for our authentication, right? So we have access to the resources that we created for anomaly detection and blob storage in this case.
Yes.
Yeah.
Yes.
Awesome.
Yeah, because the client will not work if the authentication did not work.
Yeah.
So that's why you needed to pass in the API key and the API itself. So now what after you train is going to give you a unique model on ID, and this is what you're going to use all throughout your dealings with, whether you want to infer the data or whether you want to look at the results of the training. You can use this model ID. They're different. The multivariant anomaly detection provides different APIs for you depending on what you want to do. So if you want to, let's say, retrieve the results, export the model, you have to give it the model name. Model ID that you want to export. If you want to delete that, you can do all of that.
Yeah.
So after that, after training.
Also, that means that we can train multiple models, and we will use the model ID to use those trained models. It could be, for different purposes.
Exactly.
Okay, great.
Exactly. And that's where we're talking about as you train, you can look at some of these results and see whether, are the results looking good? If they're not looking good, based upon the data that you have, maybe you need a lot more data, you can do that. So you can, if you want to list the different models, this is the API call to, based upon the client, to list the models. That's one of the APIs. Then when you're training, you can also monitor whether your model is ready or not. So you can have you can print the different statuses in there.
Okay, we are saying when the model status is not ready, keep counting, try out, and keep trying. Okay.
Yeah. So training, actually, like running this particular model, it takes like 5 minutes. So the whole time,
that's fast, actually.
Yeah, you can be like looking at the status to see, okay, is it done? Is it done? Is it done? That sort of thing.
Yeah.
So once the model is trained, well, these are the outputs that I was telling you about.
Are we going to run the first part?
Yeah.
Okay, awesome.
Hang on.
I want to see some action.
Yeah, so all of these were definitions. I was defining what each should do. So once you call the functions down here, you have your start time, your end time. You're calling the train on the start and end model. It does return an ID. You also have results. That's also calling the detect function that was defined up there. And the detect is actually the inference of the model. So you do have a trained working model now, but how do you get access to it? So you get access to it using the what's it called? The model ID. And if you notice, the next thing I provide is the test start and end point. So you actually, this is how you infer. So you test your model to see whether, okay, is it accurate or not. And the good thing is the results field brings back a lot of data in JSON format. One of the key ones that is important is the results ID, because using the results ID, you'll be able to take that and use another API that brings back all the results that you can scan and look through.
Mm-hmm.
The next thing is actually exporting your model. So if you want to export your model, you can export it and give it to your developer to integrate it with whatever web service that you have out there or whatever application that you have.
So why would the trained models, like, can people run this in their local environment? Is that why we are getting the model?
Yeah. So you can deploy this via AKS. If you unzip it, it's actually a pickle file. So you can actually do the inference of the model. Yeah.
What do you
So
mean
this
by
is how. Yeah, because everything is run in the cloud, but now you need to extract the model that you actually created. So you may want to extract it, and especially when you're using things like Onyx, where you need to figure out how you can infer it into whatever programming language that you're utilizing. That's where your model is. So you can use it whether you need to deploy to a Kubernetes cluster or whatnot. So these are the outputs that, you can put out in terms of training. So
Can you look back? Sorry, I I have lots of questions. Can we look back to the results?
sure.
Oh, model ID, result ID, and okay, great.
Yeah. So these are the actual key ones that are important. So I decided to print it out because once you train your model, it is going to return a model ID. That's how you track your models. Let's say we're to run this over and over again. When I print out, it's going to be printing multiple model IDs. So you need to figure out which one was good or whatnot. So based upon that, it also has a result ID based upon the detect when I tested with the test data, that sort of thing. Then the next thing is, okay, we do have the results. We need to figure out, okay, did they find any anomalies or not? So this is just going through the data and actually displaying the data.
Yeah, and I see that you're using Bokeh. It's a Python library for visualization.
Yeah, and it's very interactive. So you basically grab the data that you got from your training. You also give it a start and end time. And basically, what you're doing is loading the JSON file. So all of this is just bokeh. You're just looping through, grabbing
Values and timestamps.
the values, timestamps, all of those in a frame. So I put it like in a data frame. This is defining how you want your graph to look like, the colors and everything. and also how you want to format your, what's it called, your dates. Then
just to show it on the visualization. So if you're not visualizing, you wouldn't have to, but
yeah, if you're okay, that's a good question. If you're not, forget the cell. We have our model ID, we have the response ID and whatnot. You can call the API directly that, okay, bring me the results. It's going to give you a whole dump of all the data. So if you use another, let's say, thousands of data points that you wanted to find an anomaly, you're going to go through and scroll through all of those thousands of JSON files.
or
So
you use it on another tool, right? Like it's giving you the flexibility. Take it to anywhere you want, like Power BI or any other place too, if you want to visualize it. Yeah.
exactly. So for the sake of this demo, it's just graphing it here, especially when you're a programmer. It's good to visualize real quick whether or not your results came out right. So
Yeah.
hang on, since we actually maximize it, minimize the graph.
Oh, great.
Yeah, because I'm like, wait a minute, where did the data go? Okay, we're back in business, people. So,
What is this severity that you defined on 0.7 IC?
ooh, that's a very good question.
Yeah,
So
I don't know what else we missed. You are going fast. I know you want to see the visualization.
yeah, the colorful part. So the severity is very important. So as you're looking at your data, you want to know how granular or how strict it should drill down, how sensitive should it find anomalies based upon the score of the anomaly. So the higher,
between 0 and 1?
yeah, between 0 and 1. So the higher the number, the more anomalies you're going to get.
Okay, so if I give 1, it will tell me there's tons of anomalies maybe. And if I reduce it to 0.7, it might, skip some of the things that it thinks it's an anomaly, right?
Exactly. And I'll definitely encourage people to play around with this because as you're adjusting those data points, it is going to show you more fine grain where the anomalies are. So I'm not sure whether you guys can see this. Seems like we all need glasses at this point. So remember the CVS files that I was talking about? You have, let's say, for this one, we have 4 data metrics that we're dealing with: kitchen, laundry room, power, voltage. Those are different CSV files. They contain timestamp and value. So these are actually the names that I gave to the CVS file. So that's what it's reading as the data features or metric it needs to do the analysis on. So it's very important. If you name your file WXYZ, guess what? It's going to show up here, W, X, Y, and Z. And you're wondering, okay, why is W, X, Y, Z causing an anomaly?
Yeah.
So back to the scenario that we talked about. This one is for a household power consumption. So let's say I'm getting a power bill, 1 month is higher than another, or a company wants to give their residents a way of monitoring and providing recommendations of where anomalies are coming. One of the key areas that are known in a household to consume a lot of energy is your refrigerator.
Yeah.
That's a big guzzler. Also, your
Although
washer and dryer. Go
yeah,
ahead.
in this one, kitchen seems to be doing okay, other than the spike. Right?
Yeah, they must go out to eat a lot. No,
Great theory. And when they're doing the laundry, they get hungry, and
there's a correlation. Yeah, so
sensation.
exactly. So a lot of these stuff sometimes is not necessary. Okay, on the residential side, sometimes a resident can be doing things as normal, but certain things as, okay, you turn on the AC and left the window open. That will drive your bill very high. Or maybe there's a leak in your refrigerator. That's also going to skyrocket. So when you call the company, your power company, they're not going to know, like, okay, I guess you use it too much. So the voltage pretty much stays flat, which is expected. That's what's between the voltage and the available voltage and the currency. That's what charges the power. So unless it goes completely flat, then maybe we have a power outage, that sort of thing. But if you notice, whenever somebody maybe, let's say we had another field, like maybe bathroom, somebody kicks off a hair dryer for the longest time. Okay, if that brings another spike, it's just the more energy or the more power we're using, that's the energy consumption. So these were just, yeah.
Voltage dips in that point, right?
What's that?
Voltage dips in that point.
No, voltage contributes into power. I'm not a physics expert or electrical engineer, but just on a high level, if you had a smart meter that's hooked on your circuit breaker, the electrician, it reads all of those from the sensor. So this is an example of something that can be read from a smart sensor, electricity sensor. So the next thing is, and all of these we're reading from that JSON file that we got from the anomaly detector. So now we visually are seeing anomalies, but sometimes, let's say you have certain patterns, it's hard to really tell because this can easily go up, down, and it could be normal. But these are like, it really stands out. So that's where anomaly detector can fine grain and go in there and say, I see an anomaly at this data point.
Yeah, I mean, just looking at the voltage, it goes down when there's more usage, it looks like. And then there's another down which doesn't have that much usage. I was like, if I was looking at it, I would say that's the anomaly. But like, because I don't have the big picture, which is the data that we trained, yeah, it's harder for me as a human being to figure it out.
Yeah. And what anomaly detector, the key thing is it looks at an accumulative data. So it doesn't just, it's not like the univariate where it's looking at one thing. It looks like accumulation of the data points that you have. then it'll tell you where the anomalies are. And also, it also has to do with the severity too. So maybe if we crank it up higher, it'll show a little more. So that's where the sensitivity comes into picture.
Yeah. Can
Um,
we try? Can we run this? I don't
huh?
know if you have your keys there, but can we try the severity level?
Yeah, if we have 5 minutes to sit and watch,
Okay.
because we'll have to retrain.
Yes,
Do
and the
you
good
want to
thing
do
is
that?
we're going to make this available soon, right, as a Learn module, so people can try it out.
Yeah.
Okay.
Then let me finish one more point. So what I did is from that results that we got, you just sort, okay, all the anomalies and say, okay, give me the one with the highest score. So this is a timestamp that had the highest score. Then here's a sample of one record for this timestamp. If you notice, it gives true or false. There is an anomaly. It gives a severity. It comes very close to what we set, 70, and it gives a score. If there are any errors, then one thing that's very good is this API gives you contributors. So it can show the scoring, like which ones were the biggest contributors, and you can drill down and be able to pinpoint where the problems are coming from. And of course, if the anomaly is false, you're not going to see any of these extra stuff. You're just going to see true severity and score. You're not going to see all the other extra data. Do we have questions from the audience?
Not yet. Everybody, please ask it away. This is the safe space to ask the questions. And Ruth is very nice. She'll answer. She answered all of my questions. So looking at one more time while people are thinking about their questions.
Okay.
So
let me.
you are asking for the top anomaly and then printing that one. And if it was the severity was less than 0.7, it wouldn't even print anything. We wouldn't have any anomalies, right?
Yeah, it's basically, okay, which one had the highest severity when you're pulling it out. So if I say just bring an anomaly, there are probably 600 anomalies. So it's like, okay, you sorted out which ones had the highest severity, and it's finding this one.
I really like that we also get the contributing factors and like how much they contribute. It's really nice.
Yeah. Because, yeah, it would be like, okay, it is anomalous. Now, what? But that's where the relationship and correlation between the other data sets comes into play. So, yeah. Should we rerun?
Sure. Wow.
Okay. So while I'm doing that, think of questions to ask.
Since you're rerunning, can you change the severity level?
Yeah, that's what
Okay, cool.
I'm changing.
Awesome.
Because it'll be the same setting, but let me scroll over here since it's faster. So we'll set that to 9. So let me clear output. And let's rerun.
We have Marcelo from Brazil. Hola. To Brazil.
Hola.
It's so nice to have people from all around the world.
Yeah.
All right.
I wonder what time it is over there.
Yeah. Marcelo, do you have an answer for us? And I hope I'm saying your name correct. I don't know how many times. Maybe
Hello.
how many times I say this. Like, I hope I'm saying your name correctly. Maybe I'll detect the anomalies on my data one day.
Okay, so we're running that. Give me a few minutes. Let me scroll down to the end. Once it starts printing, then we'll know where we're at.
Yeah.
Um,
Really cool. Jupyter notebooks are super cool too. You can see your data and then run it at the same time too. Pretty
yeah,
neat.
it really helps me, especially like debugging. You go step by step, you put it into sections instead of doing everything all at once. Um, so one thing that Aysegul also mentioned is we do have the metric advisor. It's another cognitive service. It's built on is powered by Anomaly Detector. So this one you can use APIs, but also dashboard, but it makes it far configurable. It's like very user friendly. You go and toggle granularity, you toggle the severity. It shows you all these dashboards. One thing the graphs were showing, you just saw lines and whatnot, but it didn't show you the boundaries. So another good thing about anomaly detector is the algorithm not only shows you the actual data points that you have, it also shows what the expected, what based upon its algorithm, what it expects your value to be. So that's one another thing. Then it also has an upper and lower boundary. So how it determines whether this is an anomaly is whether or not, based upon that expected value, if your data point went outside of that healthy boundary that it has. So that's how, like, what are acceptable values within this timestamp. So that one also has a SDK. So it's meant for very common business practices and scenario-based situations. So taking this, something that, let's say you're to build something manually for, let's say, months, it condenses it and it caters to your business. You can just lift it off and it'll solve a whole bunch of things that you need to do anomaly detection. So whether you want a user interface configuration or you still want it SDK, it just condenses everything. So
Yeah, that's a great point, Ruth. And also, I would say, like, if you are like before you start using anomaly detector, like it's a good option to start from the metrics advisor and see if you need something else, because it's basically here Root had to define the visualizations and then like format the data, everything else, and all of those things are done. There's a ready to be used UI, and people who are not um, experts can also use it, right? So you enable more people. And I always think that, start using the tool that's almost ready. And then when you get to a point where you need something else, then build your own thing, because that's very expensive to build your own thing.
yeah, and the good thing about is, especially when you use it on the UI, it also shows you like root causes. So you can go into the incident and drill down. You can also configure whether you want alerts. So you can set like, okay, if this happens, you can set a whole pipeline of, okay, send an email, these alerts, or send a webhook, or even trigger a DevOps pipeline. There are different things that you can trigger based upon that. So that's taking it a step further, because realistically in real time, when business is flowing, nobody's looking at this dashboard. So the metric advisor is running in the background and goes and takes all these actions that you configure. So you choose between the two, which one you want to utilize.
Yeah. This is true for all of our applied AI services. So we are using our base cognitive services in the background to build those things, but they are kind of more ready-to-use solutions. And if it solves your problem, I would say it definitely starts there on applied AI. Yeah. Thank you.
See, I knew it. You're just here to cause trouble. Look at all the anomalies. It's everywhere.
Well, let me see. No, I don't. Oh, isn't it? Oh, okay.
So remember before, I think there was one here, or there was at least just one here, this, and something around here. So that's how granular you can play around with your severity. The good thing is the metric advisor also has that. I was hoping to do a demo of the metric advisor, but we don't have time. But in a nutshell, this is what anomaly detector does. The multivariant, when you have a slew of data points, especially, I think last I checked, you can use up to like 200,
Oh, wow.
or the number is probably more, that you can monitor where anomalies are coming from. And the key thing is not just to react when something goes wrong, but also be alerted for when things are about to go bad. And it doesn't always have to be negative, good or bad. It's just, okay, when did things change? So you could be monitoring thing when things change. Okay, maybe it changed for the better, or whatever the case is.
There might be a human interaction needed when things change. So this is a good way to alert someone to do that thing, for example.
Exactly.
Thank you, Ruth. This was amazing. Thank you for showing us, and can't wait to see the Learn module itself.
Yes.
Hey, everyone, we have more than 5 minutes, but not more than that. So if you have questions, ask it away. You can also find Ruth at Ruthie Yakubu on Twitter. And other things that I want to let you know is don't forget the Responsible AI event, and you can sign up to it. There's a link on the chat as well. Right? And next week, Seth will be here next Friday and highlighting some of the amazing guests and AI show moments of the year. Woo! This is exciting. It's a curated version of Best of show next week. So if you stay tuned, you can use the link aka.ms AI show live to sign up for the next event. Right.
Sounds good.
Yes.
Well, thanks for having me on the show, Aysegul. This was fun.
Yeah, you should come more often.
I'm just down the street.
Yeah.
Yeah, definitely.
Yeah. Ruth is joining us from New York, and we could actually hear in the background the sirens were going on.
I don't hear it anymore, but when I'm in meetings, people are like, "What is that sound?" I'm like, "What sound?"
Well, that's a good. You can have the noise sensor and take a look at the data. Do you ever do like the IoT sensors and such? Do you work with them?
No, I just had that little kit for the humidifier. What was it? The MX chip. That's the IoT one that I have. Yeah, to learn how to have like field devices and how it hooks up to IoT Hub, registering the device and getting the data coming into the stream. And it's actually cool now that you can, when it comes to IoT Hub, you can route it to whatever storage destinations that you have. So it's pretty cool. And that's going to be in the Learn module as well.
Awesome. Can't wait to see them. And
Yeah.
we have a link for the Learn modules. Can't remember, but if you want to have the free credit for cognitive services, aka the MS cognitive services free, you can always do that. And yeah, I don't have a link for the Learn module, but I'll post it afterwards.
Coming soon.
Yes. Yeah, you're amazing. Thank you so much. This is a
You
lot of
too.
information, and we can't wait to have you back.
Okay.
Yeah.
Bye, everyone. Thanks for
Oh
having me.
no, we have 3 more minutes. Hold on. We don't want Learn TV to have an empty.
So oh yeah, we had Ignite a few weeks ago. What stood out to you? Like, what were you excited about?
I was excited about sleeping after Ignite because yeah, I worked on the AI keynote by Eric Boyd, and yeah, I was really tired. So also one thing that was exciting for me is the mention of the metaverse and like mixed reality and the commitment that we have, because for those of you who doesn't know me, I do a lot of work with mixed reality and WebXR too. So it is really nice. Lots of companies are making commitments, and it's been a journey of, you know, 2 step forward, 1 step back, constantly. You're like, it's almost going to happen, and it doesn't happen. I feel like now it is happening, which makes me
Definitely.
very happy. How about you? What did you enjoy?
For me, what stood out was the Copilot and the OpenAI GPT-3 is just mind blowing and exciting. The capabilities. So I can't wait to get my hands into that and build great application, and also have like a peer programmer that keeps overriding what I'm writing.
Yeah, well, very respectful, coder, because it asks you, like, do you want this or do you want the other one? So for those of you who are not familiar, Copilot is a VS Code extension for the VS Code editor, which is using AI to figure out what you want to write. Basically, you can write a comment, and then it will give you the option to create different kind of functions. It works really well.
It does.
Yeah. One thing I really like about it is that, I'm not scared to write things in a language that I'm not as comfortable, because I know that I will be syntax corrected, and
Yeah.
keep
And the
things.
best way of writing them too. It's like you have your way of writing it, but it gives you the optimal way of coding. So it's also good for learners, people that are new to a programming language to learn.
Yeah. Yeah.
Yeah.
As you said, it's almost like pair programming, working with somebody else.
Yeah.
I have my dog around here. I could just pretend it. All right.
I hear you.
Thank you, everyone. We're so happy to have all of you here, and catch Seth's AI show next week. And we'll see you soon. Bye now.
Bye.